Chapter 3:2. Why do you need to sleep? From the Darwinian point of view, sleep is an illogical phenomenon. It does not fit into any of the theories of evolution. During sleep, animals disconnect from the real world and are in a defenseless state. The one who sleeps longer gets a better chance of being eliminated. A sleepy animal easily becomes a prey for a predator. A sleepy predator is the prey for another predator or loses the competition to a more active fellow who does not waste time on stupid sleep and uses it for hunting. If Darwin's theory was correct, then evolution would select those individuals who sleep less. As a result, the crown of creation would not be Homo sapiens, but Homo non-dorniens, a sleepless man. But an average person sleeps a third of his life, 8 hours a day, 23 years of a 70-year span. All this time, he remains open to any attack of a predator, a bite of a snake or a scorpion, an assault by a neighboring tribe, floods, fires, you name it. He can perish from a landslide or by the actions of an adversary. Finally, he lounges and does not benefit either himself or others. A horse that came to the earth long before a human, about 50 million years ago, sleeps for 3 hours daily. Lamarck's favorite animal, a giraffe, sinks into sleep for only 2 hours, and human babies sleep 12 to 14 hours a day. Chimpanzees sleep for 10 hours. Quite interesting path to the fittest creature, don't you think? Sleep is a universal phenomenon. Everyone sleeps. Tired penguins sleep, flying birds sleep. Flowers fold their leaves at night, the fish are immersed in stupor. The most primitive organism is a roundworm, Thanematode C. elegans, and it falls asleep. Dolphins manage to do it in motion. Their brain hemispheres sleep in turns. If both hemispheres fell asleep, the dolphin would simply drown. Whales and crocodiles also sleep with one hemisphere at a time, but they are sleeping. Migratory birds sleep in the mid-air. During long migrations, every 10 to 15 minutes, the bird sneaks into the center of the pack and only waved its wings lazily. It hovers on the airstreams that its counterparts create. Then the birds change places. Why everybody needs to sleep, neither evolutionists nor creationists offer an exhaustive explanation. In the old encyclopedias, we may learn that a sleep is a periodic physiological state of the brain and the human body in higher animals. It is characterized by immobility and disconnection from the stimuli of the external world. The early theories considered sleep as a state of rest and break in the activity of neurons, their inhibition. Another source of knowledge, Wikipedia, reports that the human organism physically restores itself during sleep, healing itself and removing waste which builds up during periods of activity. This restoration takes place mostly during slow-wave sleep, during which body temperature, heart rate, and brain oxygen consumption decrease. The brain, especially, requires sleep for restoration, whereas in the rest of the body, these processes can take place during quiescent waking. It would seem logical. The body is tired and it needs rest. Therefore, we fall into a sleep, and the most convenient time for sleeping is the night when you least want to engage in activities. Two facts contradict this trivial explanation. First, it turned out that brain neurons not only do not hamper their activity during sleep, but on the contrary, neurons' activity sharply increases. It appears as brain is waiting for his master's body to go to sleep and did not interfere with his concentrated work. The body worked a full shift, 8 hours. Now the brain took over the night watch. Secondly, scientists have found that sleep is not just a useful phenomenon that allows the body to rest and gain strength. Sleep is vital. Can we live without sleep? It turns out that we cannot. Deprivation of sleep leads not to a chronic fatigue, but to the physical death. Tireless researchers conducted experiments by depriving sleep of laboratory animals, dogs and rats, and then the humans. How could you conduct these experiments? In principle, not much equipment is needed. You can even do it without computer data processing programs. You only need to deprive the animal of sleep for a certain period of time and see what will happen to it. Russian Maria Manasena conducted one of the first known experiments at the end of the 19th century. This scientist took puppies and prevented them from sleeping. The study lasted a day, then another day, then a few more days. After that, with scientific consensuousness, the researcher recorded that the puppies, all of them, had died. In the 1930s, at the Leningrad Institute of Physiology, in the laboratory of Academian Bykov, another set of experiments was conducted. This time, it was a completely different level of physiological knowledge, a higher science. In these experiments, not the puppies, but adult dogs were not allowed to sleep. 6 laboratory animals were used, and curious researchers introduced the so-called methods of soft sleep deprivation into a practice. They played with the dogs, walked them, did not allow them to plunge into a dream, but dogs were not stabbed, were not beaten. No cruelty was allowed. By that time, science had learned to register not only external signs of vitality, but also internal parameters such as pulse, blood pressure, body temperature, skin galvanic reaction, etc. The animals were brought to the brink of death. After that, scientific experiments stopped and scientists allowed the dogs to fall asleep. It turns out that the critical moment is reached in just 5 to 6 days. After that, the dogs slept 10 to 12 hours and returned to normal state. American scientists worked with rats. These experiments were carried out by Professor Alan Richthofen from New York's Mount Sinai Hospital. Richthofen and his colleagues recorded electrocardiograms in rats that lived permanently on a special disc placed above the water. If the rat tried to fall asleep, the disc began to spin and the rat fell into the water. Rats do not like to swim and immediately wake up. This high-tech experiment was conducted entirely without human participation under computer control. After a while, a decisive moment was coming. The sleep-deprived rats were still alive, but suddenly, their electroencephalography becomes flat. The moment of no return was reached. If such a rat was allowed to fall asleep, it did not return to life and died. What happened during these experiments? One day after the sleep deprivation, rats' appetite increased, but at the same time they began to lose weight. An ulcer appeared on the skin, the fur falls off. When the autopsy was conducted, it turned out that the entire gastrointestinal tract was damaged. The dead rats got ulcers of the stomach and intestines. Did it happen because the rats and dogs were so tired of insomnia? No, their immune system was out of order. From the point of view of mainstream science, this fact is difficult to interpret. How does rest deprivation lead to an ulcer, loss of fur, and death? Our hypothesis explains it easily. What happens to the mechanisms of cell division if left without supervision? Remember how many bits of information are copied in the body every day? Dozens of quintillions. Sometimes, very rarely, some mistakes creep into a cell copying process. Cells, being unattended, begin to accumulate those mistakes. A mechanism of error self-correction ceases to function, and this means the destruction of the immune system. It is generally accepted that food, air, and water are needed to sustain life. These are all understandable, tangible, material things. They can be touched and measured. Sleep carries only the information components, but without these components, organisms cannot live. Hence, it is necessary for living beings physiologically. Almost certainly, you, a listener, have a personal computer. Most likely, this computer uses one or many different programs with which it knows what to do. The computer itself is a piece of hardware, and without the information embedded in the programs, does not represent any special value. A computer with its programs is incomparably simpler than any living being. The capabilities of one human brain are comparable to the total capacity of all computers and supercomputers built by mankind as of 2017. Teams of professional programmers develop these relatively simple programs. Not just develop, they constantly test, correct, and update the software. But despite this, all programs, even relatively simple, need to be debugged and updated. From time to time, a notice pops up on my screen and tells me that in the near future the program should be updated. If the software is not updated, the computer starts to slow down and eventually stops working at all. It gets viruses or cannot process new information, which an updated version of the program offers. Since, as we remember, mankind was created by the global mind in its image and likeness, we could hardly find anything better to adjust computer programs than what global mind invented in order to correct the errors in living organisms. We suspend the computer operation and correct the information embedded in it. We clean it from the viruses. We update the programs so that they interact with other updated and new programs. For this reason, global mind disconnects us, plunging into a sleep. It scans our body, all of its 30 trillion cells and innumerable organelles, corrects genetic errors accumulated during the day, and allows the functioning of the cleaned body for the next period, which is called wakefulness. For one day in a healthy person, the following processes occur. 5 to 7 billion cells die. About the same number of cells are born. Some of them have mutations. In most cases, there is one mutation per million cell divisions. If we accept this figure, then the human body gains about 6,000 genetic errors each single day. Some of these errors can be corrected by a brain itself, but to correct most of the genetic failures, a human brain's power is not sufficient. During the sleep, global mind comes to the rescue. Let us take an analogy again. People increasingly use relatively low-capacity computers connected to the so-called cloud. A cloud is a cluster of many computers that forms a powerful supercomputer located somewhere at the distance. Those who watched the film The Martian from 2015 could remember the curly genius named Rich Purnell who figured the way of saving the astronaut accidentally left on Mars, Matt Damon. Rich tried to calculate the most advantageous trajectory of the spacecraft, which was supposed to return to Mars and pick up the forgotten Damon. Rich quickly realized that neither his own brain nor a laptop had enough power to solve such a grandiose task. Late in the night, he made his way to the computer center and connected his laptop to a giant supercomputer. The big brother pondered for a while and produced a paradoxical trajectory, thanks to which the expected happy end cheers up the audience. But this is only a part of the work done during sleep. When the brain is plunged into a sleep and merges with global mind, the latter gets at his disposal a clean, uncomplicated with daily tasks, biocomputer. First, during the sleep, any information accumulated per day is transferred to the general global mind bank, and secondly, the brain of an individual being becomes part of a huge world computer. The latter may not be too fast in its calculations, but its memory and power go beyond the imagination. It is no wonder that enlightened people give global mind supernatural, mystical meaning and significance. But we are part of global mind. We are its creations and its creators.